This lecture video is about functions. So we're going to look at several things about functions in this video. We're going to look at how to identify a relation, domains, and ranges. We're going to identify whether something's a function or not. We're going to use the vertical line test to determine whether the graph of something is a function or not. And then we're also going to look at how to use function notation and how to understand that. So the first thing that we need to talk about is what a relation is. And a relation is just any set of ordered pairs x, y. So x is always going to be the first coordinate and y the second coordinate. The x coordinates are the domain. So all of the first values in the ordered pair makes up your domain. And the set of all y coordinates is the range. So all of the second values in that ordered pair will make up your range. So in order for a relation to be considered a function, it needs to meet a special condition. And a relation that assigns to each value of x exactly one value of y is what we call a function. And the best way that I've found to remember whether something is a function or not is to remember the vertical line test. So the vertical line test says that if you can find a vertical line that will pass through the graph of a relation in more than one place, it is not a function. The other way for us to think about this, and this is the way that I normally will think about this, is that if there aren't any vertical lines that intersect the graph in more than one place, then the graph is a function. So if I'm trying to remember whether something is a function or not, I draw a vertical line and I put two dots on it and I say, this is not okay. And then I think about what's going on when you have two points that lie on a vertical line. Well, if you have 2 points that lie on a vertical line and you think about their x, y coordinates, then the x coordinates are the same, but the y coordinates are different. And so that's the situation that's not okay. We have one single x value, so this would be the same x value for both of these points, but these y values are different. And that's the situation that's not okay for us to have for a function. So now let's go look at some examples, and we're going to find the domain and the range, and then we're also going to determine whether they're functions or not. Our first set is the ordered pairs 2, 3, 0, 0, -1, -5, and -2, 6. So one of the easy ways to see whether this is a function or not is to make a diagram of this relation. And so we're going to list the domain in a column, and then we're going to list a range in another column. And the domain values, remember, are the first values in the ordered pair, so that's going to be 2, 0, -1, and -2, and I like to list mine from smallest to biggest. So that would be -2, -1, 0, and 2. So they're actually backwards here. And then the range is the set of all second values in the ordered pair, so that's going to be 3, 0, -5, and 6. And again, I like to list them from smallest to biggest, so my first one then is going to be -5. And then the next one would be 0. And then 3. And then the 6. And now what we do is we draw a line showing this correspondence, that 2, 3 is an ordered pair. So we would draw a line from, or an arrow from the 2 in the domain to the 3 in the range. So this shows that these two correspond to one another. And then 0, 0 is an ordered pair, so we draw an arrow from the 0 in the domain over to the 0 in the range. And then -1, -5, and -2, 6. So there are a couple of ways that you can determine whether something is a function or not. First of all, remember up here we said that we would have the same x value but two different y values. So one of these x values would have to be repeating itself in order for that to happen. And all of these x values are different, and so that would tell me right there that this is a function. Also, we only have one arrow leaving each of our domain values in our diagram here, and so that also tells me that this is a function. And so I'm just going to list as a set our domain. So that's the set of these values here. So -2, -1, 0, and 2. And then I'm also going to list as a set the range. And our range values is this list of numbers, -5, 0, 3, and 6. Okay, so now we're going to do the same thing for this relation. We have the points 3, 1, 3, -2, 3, 0, and 3, 6. So first I'm going to list my domain. And so all of these are a 3. So the only value in my domain is a 3. And then I'm going to list my range. And my range, I have the values 1, -2, 0, and 6. So I'm going to list all of those, starting with the smallest. That would be the -2. And then we have 0, 1, and 6. And then we're going to draw arrows. So we have the point 3, 1, so we're going to draw an arrow from the 3 to the 1, and then 3, -2, and then 3, 0, and finally 3, 6. So now we see that the 3 repeats itself, and so that tells me that it's not a function. Also, we have several arrows coming out of the 3 in the domain, going out to different y values in the range, and so that also tells us that it's not a function. So now I'm just going to write out as a set the domain and range. So the domain had just a single value in it of 3. So that would just be a set containing a 3. And then the range is the set of values -2, 0, 1, and 6. And so now we have one more of these, so we're going to do the same thing. I'm going to list the domain. We have the points 1, 3, 2, 3, 0, -5, and -5, -5. So my domain has the values -5, 0, 1, and 2. And then I'm going to list my range. The range has the values 3, 3, -5, and -5, and you only list repeats once. So listing them from smallest to biggest, that would be -5 and 3. And then we're going to draw on our arrows. So we have the point 1, 3, so we draw an arrow from the 1 over to the 3. And then the point 2, 3, so an arrow from the 2 in the domain to the 3 in the range. And then 0, -5. And the last point, -5, -5. So is it a function? Well, do we have any x values that repeat? We have 1, 2, 0, and -5, which are all different. And so that tells me that this is a function. Also, there's only one arrow leaving the x values in the domain on our diagram, and so that also says that this is a function. Okay, so it's okay to have more than one arrow going into a range value, but it's not okay to have more than one arrow leaving a domain value. So now we're going to list as a set our domain and range. The domain is a set that contains the values -5, 0, 1, and 2. And the range is the set containing the values -5 and 3. So here we've seen two ways for us to display a function. One way is to list a set of ordered pairs like this. This diagram is a second way for us to describe a function, so that's two ways. A third way for us to describe a function is to use an equation, and so now we're going to determine if the following equations are functions or not. And so the same rule applies. So for every single x value, we can only have one y value that's corresponding to it or associated with it. So in this first example, we have y equals 1/2 x, and we've seen the graphs of these already. This is the graph of a line, first of all. And so one thing that we can think about is if I put one value in for x, let's say I put 2 in for x, then what's y? Well, if I put 2 in for x, then y is 1. If I put 0 in for x, then 1/2 times 0 is 0, so I get 0 for y. And if I put 4 in for x, then I get 1/2 times 4, which is 2. And anytime I say what x is, I'll only come up with one y value. And so for each x value that I put in, I only get one y value out, and so this is a function. Oops, we'll move that down here. Okay, in example B, we have y equals 3x minus 1. So again, this is also the equation of a line. And again, if I give you one x value, say x is equal to 0, then you would say, well, 3 times 0 is 0, minus 1 gives us negative 1. And each time I give you one single x value, you'll only be able to give me one y value that goes along with that. And so this is a function. And it's for the same reason that example A is a function. Because each time I give you a single x value, you can only give me one y value back. In example C, we have y equals negative 3. This is also a line. This is a horizontal line. And so is this a function? So if I say that x is equal to 3, then what's y? Well, y is always negative 3. No matter what x value I give you, y is always going to be negative 3. But you can only give me one y value. You can only give me negative 3. You can't give me any others. And since each x value that I give you, you will give me exactly one y value, negative 3, then this is a function. Our next example, D, x equals 5. This is also a line. This is a vertical line. So horizontal line is going from right and left. Vertical is going up and down. And so is a vertical line a function? So now x is always 5. It doesn't matter what y is. So on this vertical line, so will this pass the vertical line test? No. All of the x values are 5, and y can be anything this time. And so this is not a function. So horizontal lines are functions. All of the lines are functions except for the vertical lines. They are not functions. Our next example, E, x equals y squared minus 3. So far, either we've already had all of these solved for y, or in this case, there was no y, so we couldn't solve for it. But the first thing that you need to do is solve for y. And it just so happened that the first 3 examples were already in that form. So to solve this equation for y, I want to get this y by itself, so I'm going to add 3 to both sides. That will give me y squared equals x plus 3. And I almost have y, but not exactly. I have y squared right now, and the way that we unsquare something is we take the square root on both sides. So I'm just going to take the square root on both sides of this. And that will give me y is equal to, and when we take the square root on both sides of something, we have to remember to do a plus or minus. So this is y is equal to plus or minus the square root of x plus 3. So now, when I tell you that x is equal to 0, then now you're going to give me two y values, positive square root of 3 and negative square root of 3. So for each x value I tell you, you're going to give me 2 y values. There's only one x value that only corresponds to one y value, and that's -3. So if I put -3 in here, I get the square root of 0, and 0 doesn't have a positive or negative, but all other values will have 2. And so this is not a function. So what's going to make something not be a function when you're solving for y is this plus or minus. So if you end up having to do a square root on both sides, it will turn out to not be a function in that case. So why do we have to do the plus or minus thing when we take the square root on both sides? Well, the reason that we need to do that is because we don't know if, let's say for instance, so let's assume y squared was 9. So if y squared is equal to 9, then I don't know whether I got 9 because I squared -3, or if I got 9 because I squared a +3. And so we have to consider that y could have been either one of these, either a -3 or a +3. Either one of those will give us the same value. And so again, we need to consider both situations. In this last example, this one is already solved for y, and so we don't need to do that step. We just need to determine whether it's a function or not. So now if I tell you an x value, how many y values can you give me? Well, only one, because if I tell you that x is equal to 0, 0 plus 7 is 7, so that's just one y value. If I say x is 1, 1 squared is 1, plus 7 gives us 8. And each time I give you a single x value, you'll only be able to give me one single y value back. So this is also a function. The next two examples are graphs, and so when you have a graph, then determining whether it's a function or not is fairly easy. We just need to use the vertical line test. So when we pass a vertical line through this oval, it intersects in more than one place, and so this is not a function. In this graph, no matter where I draw my vertical line, the vertical line will only intersect in one place, and so this is a function. Next, we're going to look at function notation. And so with function notation, we use this notation, an f with an x in parentheses here, and we can use different letters. The f is the name of the function. And the x value is the independent variable. So a couple of nice things about function notation is that if we want to talk about several different functions, then we can name them different things. So I'm just going to scroll back up a little bit. So we can have one function called f, but I can talk about another function called g, and instead of having to write all of this stuff out every time I talk about it, I can just talk about the function f. And then when I want to talk about the function g, I can just talk about the function g, and I don't have to write this all down. Once you state this, then you can just talk about the function with their names and not writing all that stuff out. The other nice thing about it is that when you're evaluating it at some particular value of the independent variable, we use this notation, which we'll talk about in a minute. So first of all, when we read this, it's read as f of x. So that's how we read that. And so this would be read f of -2. And so this is, what is the y value, or what is the function value when x is equal to -2? So basically, this function notation is exactly our old notation for y. Like I said, it's got a couple of nice features about it. One is that we can talk about function names and not writing out the function all the time. If we are only using y, then we would have to write everything out all the time. The other nice thing about it again was being able to see this. So we're going to, f of 4 means what is the y value, or what is the function value when x is equal to 4. So that's some nice stuff about function notation. So now we're going to evaluate these functions when x is -2, 0, and 4. So first we want to find f of -2, and I'm going to switch my pen colors around here a little bit. So when I'm evaluating a function at a particular value, and particularly if you're new to this, I would write out what I call the shell of the function, and that's write out your function except for where this x is, leave an empty parentheses like I left right here. So that would be 2 minus 3 and then an empty parentheses, and then just replace the x with whatever you're evaluating the function at. So first we're going to do -2. So put a -2 in the empty parentheses there. So what do we get? We have 2, and then -3 times -2 is +6, and so we get 8. So f of -2 equals 8, and this corresponds to the ordered pair -2, 8. Then we also want to find f of 0. So again, write out your shell, and the shell is 2 minus 3 with an empty parentheses, and in the parentheses we're going to put a 0. So what do we get here? We have 2, and then -3 times 0 is 0. So you could write -0 or +0. Doesn't really matter there. And so we just get 2. And so this says f of 0 equals 2, and the ordered pair associated with that is the point 0, 2. And we have one more left to do, and that's f of 4. So we're going to do the same thing, write down the shell, and then in your parentheses, put a 4. So what do we get this time? We have 2, and then -3 times 4 is -12, and 2 minus 12 is -10. So this says f of 4 equals -10, and the point associated with that is the point 4, -10. Our next function here is f of x equals 3x squared minus 4x minus 1. So first we want to find f of -2. So I'm just going to write my shell down. So that's going to be 3 and then an empty parentheses, and we're squaring it, minus 4 times the empty parentheses, and then minus 1. And then in the parentheses, we're going to write the -2. So -2 squared is -2 times -2, which is +4. So we have 3 times 4. And then -4 times -2 is +8. And then we have -1. So that's 12 plus 8 minus 1. 12 plus 8 is 20, and 20 minus 1 is 19. So what this says is f of -2 equals 19, and the ordered pair is -2, 19. Next, we want to find f of 0. So again, we're going to write down our shell. So that's 3, an empty parentheses squared, minus 4 times an empty parentheses minus 1. And then in the empty parentheses, we're going to put a 0. And what do we get here? Well, 0 squared is 0, times 3 is 0. I'll just write that down at first. And then -4 times 0 is 0. So we have 0 minus 0 is 0, and then minus 1 is -1. So this says that f of 0 equals -1, and the ordered pair that goes with that is 0, -1. And one more to find, and that's f of 4. So write down your shell, 3 times an empty parentheses squared minus 4 times an empty parentheses minus 1. And then we're going to replace where the x was with a 4. So what do we get this time? 4 squared is 16, so we have 3 times 16 minus 4 times 4, which is 16, and then minus 1. 3 times 16 is 48, and then we have minus 16 and minus 1. And 48 minus 16 is 32, and 32 minus 1 is 31. And so this means that f of 4 equals 31, and it's the ordered pair for 31. Our next example, f of x equals negative 6. So no matter what x is, y is negative 6. This is exactly the same as saying y is equal to negative 6. So we want to find f of negative 2. And so write down the shell. And so anywhere there's an x, you put an empty set of parentheses, and we're going to replace the x with negative 2. And so f of negative 2 equals negative 6, and the ordered pair that's associated with that is negative 2, negative 6. Then we want to find f of 0. So f, empty parentheses, equals negative 6. There's no x here for us to put an empty parentheses at. And so we just have f of 0 equals negative 6, and the ordered pair that goes with that is 0, negative 6. And then we want to find f of 4. So f of 4 is equal to negative 6. And the ordered pair that goes along with that is 4, negative 6. So again, no matter what x is, y is always going to be negative 6 for this function. Okay, this was a horizontal line. And then our last one of these here, we have f of x equals the absolute value of 1 minus x. So again, I'm just going to draw out my shell. So that's the absolute value of 1 minus an empty parentheses. And in the empty parentheses, we're going to put a negative 2. So we have the absolute value of 1 minus a negative 2 is 1 plus 2. So when you have minus a negative, that becomes plus, and so that's the absolute value of 3, which is 3. So this says f of negative 2 equals 3, and the ordered pair that goes with that is negative 2, 3. Now we want to find f of 0, so do the same thing, write out your shell. The absolute value of 1 minus an empty parentheses, and in the parentheses we're going to write as 0. So we have 1 minus 0 is 1, so that's the absolute value of 1, which is 1. So f of 0 equals 1, and the ordered pair then would be 0, 1. And now do the same thing for 4. So we have the absolute value of 1 minus an empty parentheses, and in our empty parentheses we're going to put the number 4. And 1 minus 4 is negative 3, so we have the absolute value of negative 3, which is 3. And so that says that f of 4 equals 3, and the coordinate that goes along with that then would be the coordinate 4, 3. Next, we're going to look at determining the domain of a function. And when you're trying to find the domain of a function, I find it best to just go through these steps. So you're going to start off always assuming that the domain is all real numbers, and then look for problems. And there are two problems that can occur for a function. The first one is having a 0 in the denominator, and this is the key problem that we'll be seeing in this section of material. The other thing is that you could possibly have negative numbers underneath square roots, and in this section of material you actually don't run into this problem, but it is one that you could run into in the future. So this is the main problem that we're going to look for, is where could I possibly end up with a 0 in the denominator? So that would mean, where are there x values in a denominator? And then we're going to want to remove any of the problem x values that we find. So let's look at some examples of how to do this. So we're going to start off assuming that our domain is all real numbers, and then we're going to look for problems. Our two problems were dividing by 0 and square roots. So first of all, to divide by 0, we'd have to have some kind of a fraction. Well, this problem has no fractions, so we're not going to be able to divide by 0 anywhere. And there's no square roots, so we're not going to have any negative numbers under square roots either. And so the domain is just going to be the set of all real numbers. So there are several ways you can write that. You can just write down the symbol for the set of all real numbers, which is this funny capital R with the two backs on it. You could write it as an interval, which is negative infinity to infinity. We always use round brackets when we're writing an interval that's starting and ending at infinity. Infinity always gets round brackets next to them. And then you could also do this in set notation. So it would be the set x such that x is a real number. Okay, so we could do just writing out the symbol for real numbers, or we could do the interval notation, or we could do this set notation. This is the notation that they will want on MyMathLab. And this is my preferred notation. This is my preferred. I would accept any one of those three notations for your domain, though. Our next example, we have f of x equals 2 over x plus 3. So now I have a denominator, and so I need to worry about what value of x could I put into here that would make this denominator 0. Well, you can just do that by inspection, and if x is equal to negative 3, then you're going to have a problem. So x equals negative 3 is our problem. And so we need to remove that from our domain. So you could say, so this means the set of all real numbers, and then just say x not equal to negative 3. Or you could write an interval, and so to write the interval, we would go from negative infinity, and you go up to your problem, which is negative 3. Using this round bracket removes the negative 3 from the interval. And then we use this big capital U. The big capital U says take this set of numbers and add it to the next set of numbers. So I'm going to use a round bracket and start right where I left off at negative 3 and go up to positive infinity. So this is all negative numbers up to negative 3 but not including negative 3, plus all numbers not starting at negative 3, because we're not going to include negative 3, on up. Okay, so this just removes negative 3 from the domain. This is my preferred notation. And we could also do this as a set. The set x such that x is a real number and x is not equal to negative 3. Okay, so again, this is what MyMathLab is going to have. It will just give you a list of choices, and so you would select that one. On our next one here, we have f of x equals 1 over x minus 2. And so the value that's going to make this denominator 0 is 2. A positive 2 minus 2 is 0, and we can't divide by 0, so this is our problem. And so we need to remove that. So do the same thing that we did over here. So you could say the set of all real numbers except for x can't be equal to positive 2. Or we could say negative infinity up to our problem, which is 2. Use a round bracket because it removes the 2 from the interval. And then the big capital U joins the two intervals together. And then you start right where you left off, which was at 2, and go up to positive infinity. So this is every single value except for this 2. these round brackets take the 2 out of the intervals. Or we could use set notation, the set x, such that x is a real number and x is not equal to 2. Again, this is what my math lab is going to have you pick from, a bunch of these. Our next one, f of x is equal to the absolute value of 4x. So there's no fractions, there's no square roots, and so the domain is a set of all real numbers. And again, that would be negative infinity to infinity, or the set x such that x is a real number. Next, we're going to find the domain of some graphs. And so for this first one, we just have individual points. And I'm just going to put their x, y coordinates right on the graph. And so this first point right here, the x value is 1. And the y value is 5. So that's the point 1, 5. This point has an x value of 3 and a y value of 5. And this point has an x value of 4 and a y value of 2. And this point right here has an x value of 6 and a y value of negative 2. So the domain is the set of all the x values, and all the x values are 1, 3, 4, and 6. And then the range is a set of all y values, and that's going to be 5. You only list it once. 2 and negative 2. And I like to list mine from smallest to biggest, so that would be negative 2, 2, and 5. And again, you don't list repeats, you only list a number once when you're listing a domain or a range. In our next example, we have a piecewise defined function. And so first we're going to do the domain, and I'll do the domain and range in different colors this time. So first it's the domain. These are values of x. So where on the x-axis is their graph? So I'm going to assume that there are arrows on this and that goes on forever. Okay, so this goes to the left forever, right? And we get to this place and there's sort of this special spot right here where it's jumping, but those are still filled in, and so it goes on forever. And actually, for this to be a function, one of these is going to have an open dot, and the other one would have to be closed. You can't see this graph very well, but that's the way it's really supposed to be. And so the domain then is negative infinity to infinity. So there was graph everywhere above and below the x-axis, above or below the x-axis, I should say. And then the range is a set of all y values, and where is their graph on the y-axis? Well, is their graph way down here? There isn't any graph when we look right and left down here. There isn't graph until we get up to right here. And then there's no graph again until we get to this one single value. So there are only 2 single values in the range. When you're listing single values or individual values, you use set brackets. So it's going to be the set, and this x-coordinate, which is negative 1, and then, this y-coordinate, which is negative 1, and this y-coordinate, which is positive 1. It's hard to read because it's kind of blurry. But we're just listing these 2 single values. Y can either be negative 1 or y can be positive 1. No other y values. And one more of these to do, and again we'll do these in red and blue. So the domain, again this is a set of all x values, and so this does stop on the ends here, and so go down to your x-axis. So we have graph from there up to right here. And these are filled in dots, so for filled in dots you use a square bracket, and that's negative 3, and it goes up to positive 3. And we use square brackets at both these ends because this is filled in. Okay, so a filled in dot means you use square. Open means you use round. And then we want the range. The range is the set of all y values, so there's no graph way down here. The graph doesn't start until we get to right there, and it goes on up to right here. So that's our range, and you list them from smallest to biggest. And the smallest value down here is 5, and it includes the 5, so we use a square bracket. And it goes on up to this value up here, which is 14. And again, these are filled in dots, and so we use a square bracket for that. Now we're going to use this graph to answer the following questions, and this might be a little bit hard to see, but this is a filled in dot, and this is an open dot. And so we want to know, what is the y value when x is equal to 1? So we're going to go to 1 on the x-axis, which is right here, and we go up till we hit graph. An open dot is not considered part of the graph, and so that would be where our y value, this would be our y value when x is equal to 1. This is not because it's open. This is filled in. And we go over to our y-axis and we get that y is equal to positive 2. Now we want to know what's the y value associated with x equals negative 1. So we're going to go to negative 1 on our x-axis, which is right here. Go up till we hit graph, and then go over to the y-axis and we get that y is equal to 1 there. Now if the y value, so this is saying y equals negative 1, we want to find all of the x values such that y is equal to negative 1. So we're going to draw a horizontal line at negative 1. So here's negative 1. And so we're crossing right there and then nowhere else. And so then we go up to our x-axis and we see that x is equal to 4. Now this is saying y equals 0, and we want to find all of the x values associated with that. So this is the x-axis. So we're crossing right here, which is kind of a bad point, and then right here. So x can be equal to 0. So x is 0 right here. And here x is equal to 3 3/4. You have to kind of guess because it's not exactly on a tick mark. Now we're saying that y is equal to 1. And what are the x values associated with that y value? So now draw a horizontal line at y equals 1. And so again, we're going to have to kind of guess there. And then it's crossing. This one doesn't count because it's open, but we have a value right there as well. So x could be negative 1. Whoops. Or right here, x is, so it's 3 and it's a little bit less than a half, so we'll say that it's 3.4. Okay, that is the end of this lecture. If you have any questions, let me know. Thank you.